Okay, and now we turn to English. We are so happy to have Rob Lloyd and Josh Giegel from Hyperloop with us today. And I don't know if both of you will make a presentation or if it's you can do it in the way that suits you best. We are looking forward to hear what you have to say about your interesting new technology, how to have a really fast train technology introduced into the market, and also, as I understand, a bit more cheap or less expensive than the high-speed rail technologies that we speak about today. So it's an honor to have you here, and please welcome to make your presentation.
Thank you very much. So thank you very much, Björn, and Mr. Ambassador, thank you very much for hosting us at today's discussion. Just as way of background, my name is Robert Lloyd. I'm the CEO of a company in California, in Los Angeles, called Hyperloop Technologies. For 21 years, I worked for Cisco Systems. For 8 of those years, I ran Cisco's business in Northern Europe, and I've always recognized the Nordic countries as many of the first innovators for technology that our company at the time brought to the internet. When I think of the development of the internet and my own opportunity to see a network developed that transported bits faster than we could ever imagine, you can imagine how exciting it was for me to discover there was a company that was looking at a new network that could transform and transport people and atoms in ways that we never thought possible, and that's what we're going to discuss today. The idea of Hyperloop was founded and brought to the world by Elon Musk. You may recognize him as the founder of Tesla, of SpaceX. And he was pretty much disappointed with the fact that California announced a high-speed rail system that was based on technology fundamentally a century old, that didn't really go places that would add value, that was going to be extremely expensive. So in 2013, he circulated a white paper and said, I'm very busy building 2 big companies, and I would like the community to embrace some of the principles around the construct of Hyperloop, the cross between a Concorde, a railgun, and an air hockey table. So let me bring that into more clarity for you. Our company, which was founded a year ago, is actually building the construct of Hyperloop. Hyperloop will be a transportation system built in a tube, and inside that tube we remove the pressure, because when you just think of those long tunnels that we heard about that would connect the area, one of the problems with a tunnel is you create a very large column of air that you need to push all the way down through that tunnel. So by reducing the amount of pressure in a very long tube, you actually reduce the resistance required to move an object very quickly. Then we actually levitate a pod which could contain freight or people inside that tube. We levitate it probably using magnetic levitation or air levitation, so there's no wheels. That pod runs on a track to keep it online. And then we use an electric motor to move this pod very quickly inside the Hyperloop infrastructure. That motor is only required for a proportion of the time, because we have very little air resistance. As a result of this system, we actually have a system that is uninterrupted by weather because it's in a closed environment, that requires very little right-of-way interaction because we actually can build that tube above ground or underground or underwater. It's effectively carbon-free because we're not using any fossil fuels. We just use an electric motor. It propels the pod. It's extremely cost-effective, around 60% of the cost of high-speed rail. It's driverless, it's very safe, it's extremely fast because if we go relatively straight, as is in the environment in a tunnel, or in a very direct environment that isn't following railroad tracks or roads, we can achieve speeds in excess of 1,100 kilometers an hour. That means that the travel that we've been discussing today is minutes. That means we're going faster than an aircraft. And in many cases, we're going city center to city center, and we have an on-demand system that we're building. So what Hyperloop is intended to do is to solve 2 problems. We can move both cargo, including a very large container, a 20 or 40 foot equivalent container that could be included in a pod, or of course in people that will not have the same tolerance to high G-forces and high turns, so we may go slower in some cases. We'll build extra safety features into an environment that's moving people over that is moving cargo. We could move both cargo and people in the routes that we're discussing here today. And perhaps most importantly to this discussion, we can build the Hyperloop above the ground. We can build the Hyperloop beneath the ground in a tunnel. We can build the Hyperloop underwater. And because we're building a tube, we can actually significantly reduce the cost of tunneling, and we can significantly reduce some of the other construction costs that are typically associated with a very complex rail project. I've learned as I've joined the company that the typical right-of-way, the land that must be required from farmers or from private landholders for a high-speed rail system, including the service roads and the berms that are often required to keep a safety distance, is up to 70 to 90 meters. The right-of-way that's required to build a Hyperloop is no bigger than the width of this room, where we can build a pylon and then actually build the tube on top of that, or in the case of tunnels, build much more cost-effective tunnels than the current tunnels that are contemplated for either rail or road crossings. Because remember, in a tunnel, we don't need to push a very large column of air, which would be an engineering challenge in the alternatives. So if I can ask Josh now to actually take this down to the next level. Josh, by the way, is the first employee of Hyperloop. Our company was founded by the 25th employee of SpaceX, Brogan Van Brogan, and I'll come back to you in just a second and suggest maybe what we think the next steps are relative to this project. So Josh?
Well, thank you all. Thank you, Rob. But talking last night with Otto and Martin, we now understand how good the Nordic environment is for Hyperloop. And with the islands, the connection, I think Hyperloop is going to offer a way to connect these cities in a way that you haven't seen in the past, really ever. So we're looking at a route from Stockholm to Helsinki on the order of 25 minutes, what that can do. And that's part of a larger network that connects Hamburg through the St. Petersburg area. And if we focus in on a particular example, the Helsinki to Tallinn tunnel example, if we look at what a typical ferry takes, that's over 2 hours. An airplane ride there is almost 2 hours when you consider getting to the airport, considering doing all of these different things. With Hyperloop, that's a 6-minute ride. So pause for a minute and let you guys think about what kind of transformative effect that can have on the greater environment and the local connection between these two countries. And as we move forward, both from an engineering standpoint, performance, and our performance is speed, it's also important for us to do that sustainably, environmental friendly. And I was glad to hear all the presenters before talk about how important that was to this area. And I think we embody that in a way that no other transportation does. And that's 10 times more energy efficient than the ferry that's running that current route, and then over 5 times more efficient than the typical plane doing that. And that's the drive, in addition to the performance, but why this is really the new technology. So that route you may have seen is, obviously underwater. So the next logical step for that is, what else can you do with underwater capability? And that's, what about offshore ports? What if we took a port that's historically in a very expensive, very populated area, and we move that out to sea? So the ships or anything would dock with these ports, and they would then transfer their cargo or their people to an inland port, which allows a much different way of goods to flow. And as you think about it moving forward, this ties in with the last mile. So whether that be autonomous vehicles, drones, the trucks that we saw, it scales in a way that current ports can't. So if they run out of space, they run out of the ability to add more capacity, right? With this, we just add, another one of these ports out and develop the transportation structure in. And then lastly, if we look at what that does for the environment and the local environment of what is happening at the ports, this is the Port of Marseille. So this entire area here is devoted to port operations. And it's a beautiful area that's very industrial, very, prime to be given back to the people. And if we do that, we can redevelop this here. So this one port alone, over $200 billion worth of real estate development potential. And that's by moving this port up here, offshore to the offshore dock. And if you think about what that would mean for Helsinki, for the general European environment, as well as the world, that's really a transformative technology. And so we talked about the offshore ports, what those can do, the new cities, but the distributed cities. It sounded like 60,000 people a week travel between Tallinn and Helsinki, and so those people will now be able to do it on a daily basis. You know, and imagine how much more enabling that is for the rest of the countries to do that. Distributed factories, locating in the Nordic areas, factories for all of Northern Europe as well as Europe proper, and that really is going to give an economic advantage to the Scandinavian countries. Fully customizable systems, as well as some of these, you know, simplified type of customs by having discrete entry and exit ports. And then, kind of putting it all together from what Rob talked about, is that we really have kind of 21st century problems now when it comes to transportation, saturated infrastructure, you name it. And so we can choose to continue to invest in the way my grandparents and my great-grandparents got around, which was planes, trains, automobiles. Or we can invest in a 21st century solution to that problem. And so we can keep building these old things, or we can choose to do something new that's on a cost-effective, a way to enable people to communicate and get to other people in a way that hasn't been done before. And then to kind of reinforce what we're doing is that we've shown some pretty pictures, but there's a lot of science, a lot of technology behind it. And this is what's happening in our headquarters in Los Angeles. So as Rob mentioned, I started about a year ago as sort of employee number one from a garage. Now we've got over 70 people, and we've built quite a few different test rigs, some of which are world kind. A lot of automation, a lot of robotics going into what we're doing here. One of the benefits that we have being a new company is we're not inhibited or hindered by the old way of doing things with these large companies, so we can do what's really the latest technology benefit. We've got a little rig here that tests our levitation technology. Moving this over to two sides, so this is a 3.3 meter diameter tube. That's what our test unit will be. I'll talk about that in a second. This is a wind tunnel. To Rob's point, our low pressure environment is very unique, and to simulate that, we had to build and design our own wind tunnel. And the scale at which we're operating at, we designed and built that in 10 weeks. This right here is a linear motor, and that's, as Rob said, how you put that at the beginning, you put that at the end, and you have these little boost stations, and very similar to roller coaster technology or something like that. And then this is part of our office space in the Los Angeles area. So growing very, very fast. And all of that's going to the big moment. So what we're calling Kittiak. So before Kittiak happened, the only thing that could fly were birds and balloons. After that day, people could fly. So that's what we're going for. So at the end of next year, Hyperloop will fly, so to speak. And that's going to be a full scale, fully operational, and full speed test, and that's going to demonstrate the core elements of Hyperloop. So ultra low pressure environment, the compressor on the front, the levitation system that we're looking at, as well as the propulsion. And that will be the time that you know that Hyperloop isn't science fiction, it's science fact. And that is as big of a day for us as it was for the Wright brothers. And so with that, I'm going to turn it back over to Rob.
Thank you, Josh. So what does that all mean? First of all, in order to make that happen, in the time frames that we're discussing, to have a fully proven system by the end of next year, and then to begin to look for the projects in the world that would have the biggest impact as we deploy that technology, we're having to attract some of the smartest engineers and some of the brightest people in the world. Josh is one of those, but we see people coming from these kinds of companies, PhDs, masters in engineering. I think the last 3 people we hired were MIT graduates, and in the last 3 days, 8 people on Friday before we left to come here. So this is a very talented group of people operating in a new style company that is going to achieve some things very quickly. We're raising a lot of money. That 3-kilometer test project is a $100 million project that will be completed in the next year, and then shortly after that, we'll be raising hundreds and hundreds of millions of dollars to invest in the next wave of our company's development. Helping us do that is a world-class board of directors. Shervin Pishavar is the co-founder of this company, along with Brogan Van Brogan, employee number 25 at SpaceX. Shervin is a very significant owner in Uber, He's a significant investor in Airbnb and some other very interesting businesses that I'm very familiar with in the California area. David Sachs was an original founder and early employee at PayPal. Founded a company called Yammer, which was purchased by Microsoft. I spent 21 years at Cisco. We have Emily White as well on our board, who was at Google, Facebook, and Snapchat. Jim Messina was our first outside director. He was the advisor to the President Obama's original election campaign and then became deputy chief advisor, as well as recently helping run the Cameron campaign. So he actually understands the trends of people and what's happening and how deeply people feel that transportation systems are not meeting their requirements today, and everyone is so hopeful that a new transportation system will evolve like Hyperloop. Peter Diamandis, you may recognize him. He founded the original X Prize contest, which asked the community to self-fund projects that would take people to space and safely return them. The winner of that prize became Virgin Galactic, which you may recognize today as actually conducting space travel, and Joe Lonsdale, an early founder and venture capitalist. So to do this, we're going to need to be very creative, and we're going to need to move at a speed which would not be typical with innovation in transportation. But because the time is now. We see this discussion today. We're very encouraged by this discussion. There is a requirement for something different. We're going to see an 80% increase in cargo containers. We're going to see a doubling of air traffic in the next 35 years. And unless we build new airports, unless we expand our ports, our highways are continuously running out of room for people and trucks. We think something new needs to happen. And we do believe that Hyperloop could be that something. So one of the things I'd like to just leave this discussion with is having had the personal experience as to how Northern Europe, Nordic countries, have often been innovators in the world of information technology. I would like today to offer to fund the first phase of that investigation or that study. Without any government money, we would be very prepared to fund the first phase of the feasibility and engineering study for the Stockholm to Helsinki link. That's the business we're in. I'm very encouraged by this discussion and by this meeting, and we would like to partner with local sponsors and local businesses to help fund that first phase of the study so we can actually get to the next level of detail in regards to the discussion of today's topic. So thank you very much for letting us attend, and I'll see you perhaps during the coffee break. Thank you.
Thanks, Rob and Josh. That was really fascinating to listen to. Since you are not part of the panel later on here, perhaps 2 questions or so. I think there are. Do you have your mic still? You can. Yes. I thought one thing was perhaps when you are speaking about this and when you are thinking about having people transported in tubes without any sight outside and everything. What about the acceptance? Would you think that people will accept this new technology, that they will dare to go into these tubes and be transported in this high speed?
So,
please come up so people can see.
That's a very good question. We actually think you need to create an entirely different experience. Something that's very customized. Maybe I want to watch the landscape go by on a screen, or perhaps I'd like to, if I'm a business person, like to see today's stock updates. But you know, I flew here on a flight that was a 380 aircraft, an A380. The windows automatically darken. Everybody shuts their window shades. We're so used to emotionally trusting the fact that when we're at 42,000 or 38,000 feet that we're in a safe environment. In fact, if we're very close to the ground and there was any breach, the catastrophe is the tube fills with air when we're above the ground, and air is a natural brake. So we have to create a new experience for people to feel comfortable in that new experience. We require very smaller stations. You know, when I came through Heathrow, that's a massive shopping center because everyone's waiting for their flights. You don't need a large shopping center to stop at a town. You need something much more like a metro platform, because we're really talking about moving smaller packets, as I relate to in my old networking days, but we'll move packets more frequently. We'll be able to on-ramp and off-ramp from that main line. The problem with high-speed rail is you often stop. If you go fast, then you stop. You go fast, then you stop. So we'll be able to actually weave more stations and include more towns and communities in the construct we're describing today. But we do need to create a new experience so that people are comfortable in this new experience.
You also said that it was more or less on demand. The philosophy of it was on demand. Could you explain that, perhaps?
Yeah, that's actually really important, because we're going to have not a train. So don't think of a train. A train is something that has a schedule, and we all need to get there, and there could be 1,800 people get on a train and then 1,800 people get off. When we land at an airport, we think of all those big aircraft arriving and we all get in line for customs. So think of 28 to 30 people in a Hyperloop pod, or 1 or 2 cargo containers. And that means you move them much more frequently. I don't need to think that the flight that I'm supposed to take home today is leaving at 3:30. I just go when I want to go.
That's good. Another thing is, do you believe it?
I don't need to catch the ferry that leaves the dock at X. I just go when I want to go, and then I go point to point. So the idea of packets is, like, imagine what we think of today on an elevator. You get in an elevator, and if it's in a very large, tall building, typically they've broken the elevator into certain floor levels. The best thing you want to do is hit 23, and when the door opens, you're at 23. And that's the idea behind Hyperloop, is you're not going to stop at every stop. Your packet will go to the end destination.
Fascinating. What about the goods transportation, the capacity? You say that you will send them bits by bits, also goods, and it's not long connected.
No, it's not a train.
No.
We have a number of our initial investors are major port owners. And Josh gave the example of reclaiming port lands, or finding ways to build inland ports so that we can actually reclaim the most valuable real estate in the world is typically in the ports that became those first hubs of trade. But right now you should think of the fact that our freight systems are usually there's choke points, there's clog points where they stop and they wait for weeks while these massive container ships, how many containers would be on a new Maersk? Thousands of containers that offload and then they get stacked in the ports. We would envisage just actually offloading a container ship and dropping it directly into a Hyperloop pod and moving that quickly, perhaps to an intermodal place that's on real estate that people hadn't thought was that valuable previously, opening up the real estate that's in the center of cities so people can enjoy that real estate in the future.